Okay, so what we're going to look at today is the surface area of a rectangular prism. It's a bit different to volume, obviously, but when we're dealing with the surface area, and I'll do this through an interactive GeoGebra thing, what we're looking at is exactly what the name suggests, the area of every single surface. So one way we can look at it is this is a rectangular prism. It's made up of 6 rectangular faces. So we can look at the area of those 2 faces, plus the area of those 2 faces, plus the area of those 2 faces. So we're finding the area of 6 different rectangles, or really 3 different rectangles, and then we're doubling it. So there's 2 ways we can do it. We can look at all those different options. Again, there's the top and the bottom, and then we've got the front and the back, and then the 2 sides. The other way we can think about it is if we just decompose this into the net. Now this solid it's got length 6, 1, 2, 3, 4, 5, 6. It's got width 4, 2, 4, and a height of 5. If we recreate or pull that solid apart, what we get is this net. And this is a nice simple net, and that is the exact surface area. So we've got the area of this plus this, the area of these 2 sides, and the area of these 2 sides. And we can go through those options again. There's the top and the bottom, so that's 4 by 6. 4 by 6 is 24 plus 24, 48. This is going to be 5 by 6 and 5 by 6, so 30 and 30. 5 times 6 is 30, 5 times 6 is 30, or the last one, which is here, and what's that? 5 times 4, which is 20 and 20. So I think it's 148 if I remember correctly, or we can look at it in terms of different things. If we create that rectangular prism. So if we look at it like this, here we've got another one, a nice, a different one. Perhaps this might be something nicer for you to look at. This is a 5 by 4 by 3 rectangular prism. If we want to find the surface area, the area of every surface, we can look at this net. Okay, so this side here is 5 by 3. Here it is here, 5 by 3, 15, and there is 2 of them. This is going to be 4 by 3, this side here. Here it is here. 4 by 3 is 12, and there is again going to be 2 of them. And the last one is the top. So what's the top? That length there is 4. That length is 5, which is 20. And obviously there's 2. There's a top and the bottom. So here, 5 times 4 is 20. 5 times 4 is 20. So, and that's exactly how we do it. We found the area of this colored part. 2 times 5 times 4. Why did we times it by 2? Because there are 2 of them. The front and the back is 2 times 5 times 3. Again, there is 2 of them. And the last one is the 3 times 4. And again, there is going to be 2 of them. We just add them together. So different ways we can look at the surface area. Suppose we've got a triangular prism and we wanted to find the surface area of this triangular prism. What have we got? We've got the base is 3. The height of the triangle is 5, but the height of the prism is 6. So for the triangle, you're going to have to use a half of 3 times 6, and there is 2 of them. And then you've got 2 sides here that are the same and 1 base. So if we open up that might help us see it. We've got this triangle here, which is going to be 3 times 6, but you've got to halve it and then double it because there is 2 of them. Find the area of these 2 sides, double it because there's 2 of them, and then find the area of the base. So sometimes it's nice if we pull the thing apart, or at least imagine we're pulling it apart, and look at the net, and you're finding the area of the net. Hope that explains. I really like the visual of when we're looking at the surface area of this solid, this is what we're really looking at. I think that really explains it quite nicely. Okay, so hopefully that has helped you understand a little bit about when we're talking about surface area, That is what we're after. Obviously, surface area, because it's an area, it's measured in centimeters squared. Even though we're talking about a 3D shape, we're talking about the surface area, the area of all the surfaces added together.